So yeah, I was asking, this is your midterm exam or first term exams? Like say it is like quarterly or is it like midterm exams for you? Guys, are you able to hear me? Are you there?
Yes.
Sir,
Yeah,
this is terminal exam, sir, for me.
this is terminal exam.
Yes, sir.
Oh, but we didn't complete a lot of sub chapters. I didn't know that it was your midterm exams. If it was midterm exams, you'd have kept some extra classes. We'd have completed P block, something we could have done, right? Fine. Okay, I didn't know that this was your first, but first term exams will generally come in. Okay, first term if it
That's
is.
going to come in November or December.
Yeah, exactly. November or December is what I was expecting, right? First terminal exam, that is half, say into the half of completion. It's like that. That only is first term, and second term will be normally March or April. That's what I thought. But again, I don't know what is this thing. But anyways, I really think that this is not your term exam. This is your midterm exam conducted by your school. That is how I see it. Right. Anyways, no problem. Okay, so let me ask you some questions and fine. So if I want to convert, say this is conversion problem. Say I have 1, 2, 3, 4, 5. I have this to get converted to this. Yeah, can you do this conversion, people? I'll give you 2 minutes time.
Sir, are you presenting the screen?
Oh, did I not present the screen? I am so sorry.
No, sir.
Oh, I'm so sorry. Yeah, now it should be fine. Yeah, so I want you. Yeah, are you able now? Is it fine? The screen, are you able to see? Guys?
Yes, sir.
Yeah. So this is the conversion I want you to do. Think about it. If you have finished, you can send me in WhatsApp. Just click it. Suryamithu, I think you have to mute Kanha. Yes. Okay. Right. Yeah. So once you've completed, you can send me a click a picture and send me in WhatsApp. I can look into it. Or if at all you don't want to send, you can unmute yourself and tell. So this is what I did to do this. Guys, if you don't participate, it will be very boring, this class, right? The more questions you ask, the more you participate, the more interesting it will be. So what I'm doing here, I'm just skipping, like say, I'm just transferring this double bond from this question to the next question here. That's what I'm doing. So think about it. Yes, any answers, people? Or you're still thinking? Two-step reaction we can do, and you're gonna get this. Are you guys trying or no? Anybody got any answer? Or at least our first step, I think we can do in this way. Say first step is this. Any comments?
Sir, I'm not really sure, sir.
Yeah, sure. Whatever comes to your mind, what do you think can be done?
Sir, I first tried adding HBr, sir. Marconico's rule.
Marconico's rule. Okay, fine.
After that, I don't know, sir, how to add a double bond deposition.
How do you remove a double bond? Say if I have CH3, CH2, Br, say for example, I want to convert it into CH2 double bond CH2. What should I add here? What is the reagent? Anybody? This reaction is what is called as, I don't know whether you remember, it's called dehydrohalogenation. Dehydrohalogenation means basically removal of HBr or HX in general. So what is the reagent we use here?
Sir, sodium.
Sodium?
So sodium metal.
Sodium metal? No, sodium metal will not work.
Plus sodium chloride.
What? Someone was saying something. What is that? Now remember, guys, the reagent you have to use here is alcoholic KOH is what you have to use here, right? Or they will mention it like this. They'll put the arrow mark. They'll put KOH in ethanol. Something like this they will tell, right? So now basically what do you mean by this is that KOH is dissolved in ethanol, right? KOH is not dissolved in water. It is dissolved in ethanol in this case. Right. So if I want to express KOH dissolved in water, then I'll represent KOH aqueous. Right. Now that will give me a different product. I think this question we asked, I mean, we even solved, I don't know, a few classes back.
Sir,
right?
I thought it was NaOH.
Yeah, NaOH also you can use. It can be KOH or it can be NaOH. But you have to mention this ethanol. Alcoholic NaOH or alcoholic KOH is what you have to mention. Alcohol means basically you have to use in ethanol. Okay, right? NaOH or KOH, both are okay. Right. So now here what you have to use is basically say NaOH or KOH in ethanol is what you have to use. Ethanol is C2H5OH. Right? Or you can just write alcoholic KOH, put an arrow mark and write alcoholic KOH or alcoholic NaOH. That will do the trick. Okay, now what is the difference between alcoholic KOH and aqueous KOH? Say for the same reaction, if I put aqueous KOH, what would have been the product? If I put alcoholic KOH, this is the answer. A double bond, that is Br from this and H from this will be removed. So make a double bond here, right? Now, if I put aqueous KOH, then what will be the product for the same reactant? If I put aqueous KOH, what will be the product? Any guesses? So this could be the product.
Sir, will it become will it become an alcohol?
Yes, it will become an alcohol. So the thing is, people, in this case, this is going to supply OH minus, right? Obviously, when I dissolve KOH in water, what will happen? K plus ions and OH minus ions are produced. And this OH minus ions will undergo a nucleophilic substitution, say SN1 or SN2. Doesn't matter. OH minus will attack, Br minus will be gone. So the product would have been CH3, CH2, OH. Very simple. Right. But when I do alcoholic KOH, when I dissolve it in ethanol, there is no OH minus produced. No. Right. OH minus is not produced. Okay. Now then what is going to happen here is that this KOH, if I dissolve in ethanol, the only role it has is to act as a base. Right. If I just dissolve KOH in ethanol, the only role in this reaction it has is that it is going to act as a base. And remember, base is the one which will abstract the proton, abstract the H plus. Okay, so if you're wondering what I'm trying to say, this is what is going to happen, people. Say you have CH3, CH2, Br, right? Now what happens is the base. Okay, first, okay. So the first step can be Br minus leaves. Okay, first step can be Br minus leaves. So what will happen if Br minus leaves? Br minus, you have to show the arrow like this. Br along with the 2 electrons here. There are 2 electrons here, right? So along Br along with these 2 electrons will go out as Br minus, right? So if it goes out as Br minus, what will be remaining is again a carbocation. You don't have to remember this. I'm just telling you for your understanding purposes. Okay, so now now you know this is the famous carbocation, right? Now the base will come. The base will abstract the H plus from this carbon, right? It is going to have minus H plus, right? The base will abstract this proton. So what will happen now? CH2 double bond, CH2 is formed. Very simple. Okay, right? So first step is Br minus leaving, and the base which is there, that is my KOH, in this case, is just going to abstract a proton to form an alkene. Double bond is formed. Right? But if I'm going to have aqueous KOH, OH minus ions are produced, and the role of the KOH here is going to act as a nucleophile. Right? But if I put it in the alcoholic KOH, the role of the KOH is to act as a base. Base means abstracting a proton, H plus. Nucleophile means undergoing nucleophilic substitution reaction. Yes, everybody understood the difference between alcoholic and aqueous KOH. Is it fine? Yes, no?
Yes, sir.
Okay, right. I hope everybody is clear, right? So fine. So first step, what you told was correct. We're talking about this conversion here, right? So now, if I put HBr, right? If I put HBr, what will happen here? Basically, you have to follow Markovnikov's rule.
Yes, sir.
Right? So now Markovnikov's rule says that the Br should go to the highly substituted carbon. In this case, it has to go to this particular carbon, not this carbon. This carbon, it should not go. It goes to this carbon, right? So now when I put HBr, I'm going to get Br here. No issues, right? Now what I have to do? Now I have to make sure that the double bond is formed between this particular carbon and this particular carbon. Is it not? The double bond should be there. That is what is mentioned here, right? Obviously, I have to use alcoholic KOH or alcoholic NaOH, whatever it is, right? Now you must ask me, sir, the double bond can either be said, it can give 2 possible products. One is this double bond formed here, the same product you can give, right? Basically, Br from this H from this. If it leaves, then double bond is formed here, right? But say if the H from this is removed, this H is removed, and obviously you are going to get this product, but basically Br from this, H from this will make a double bond here. The double bond is here. Right? Now, which is correct? This is correct or this is correct? Or say, which is the major product? Both of them will be in the reaction mixture. Which one is the major product? And why do you say so? Guys, do you understand how there are two products? Because there are two available hydrogen. This particular reaction, right? This elimination reaction, this particular reaction is what is called as elimination reactions in organic chemistry. Right? Now, especially this reaction is what is called as beta elimination reaction, because beta hydrogen is removed. The hydrogen is removed from the beta position. Wow. So remember this. Carbon atom containing the functional group, is alpha. Remember this, right? The carbon atom which is containing the functional group is my alpha carbon atom. Obviously, the next carbon atom would have been the beta carbon atom. So, for example, if I say CH3CH2Br, now the carbon containing the functional group is my alpha. This is my alpha carbon atom because it contains Br, the functional group. Obviously, the next one is beta. Right? Now, where do you remove the hydrogen from? The hydrogen obviously is going from the beta position, right? So obviously, when I put alcoholic KOH, you are going to get CH3, CH double bond CH2. This reaction is also called as beta elimination because the hydrogen is going from the beta position. You can see it is going from the beta position. Right? Now, like this, I have two beta hydrogens here. One is this particular hydrogen which I have marked, right? And obviously there are other possibility that I'm going to have another beta hydrogen, right? So how many ever types of beta hydrogens I have, that many products will be there. If I remove this will be the product. If I remove this hydrogen, then this will be the product. So both of them will be there in the reaction mixture, both of them will be there in the product side, but which will be in major amount? Which is the major product? What is the answer to this question? This or this? Say I'll ask one, this is product number one, this is product number two. Let us all go to the chat box, people. I want you to put in the chat box, just guess which one is the major product, one or two. Everybody should participate. I'm looking at the chat box now. One or two. Let me show you which is one, which is two. Right, hope you're all able to see. Oh God. This is too much small. How do you move this? Okay, Nanda Kishore says one. But we hope you all understand if I'm showing this. This is one and this is two. Right? Okay. Come on, everybody put their answers here. I want everybody to participate. Doesn't matter whether it's right or wrong. Okay, Satyapriya says one. Okay, fine. Okay, Venisha says one. Okay, okay. So Shankar says one. Come on, everybody. Put your answers. I know still people are there. Just put one or two. I can call names if you want. Neha. Are you there, Neha? Can you put your answer? There are so many. Okay, fine. Why one? Anybody can tell me. On what basis you're telling that one is the answer? Yeah, one is correct. Okay, the one will be the major product. Why one is the major product? Why one is the major product? Like Zaitsev rule, there is one more rule, right? What is the name of the rule? Sorry, and I told the answer by mistake. Like Markovnikov's rule, there is one more rule, right? What is the rule? Sorry?
Anti-Markovnikov.
Markovnikov, anti-Markovnikov are opposite. Like Markovnikov is for addition reaction, right? Markovnikov or anti-Markovnikov, doesn't matter. Both of them are for addition reactions, right? Now there is one more thing for elimination reactions. Just like this, when I have elimination reactions, I have one rule to follow. What is the rule? Like Markovnikov's, there is one more rule. What is that? How can you not remember? There is something called as Zaitsev rule. Yes, have you at least heard of this, guys? Did you hear that some rule called as this? Everybody knows that, even though you don't know the rule. But do you know that this rule exists? Yes, no? Guys, have you heard this kind of rule exist? Have you seen in your books this rule?
Have you seen this?
Nobody has seen this. How come? How come possible? See, when I have a problem like this, right? Now I go for alcoholic AOH, right? Now please understand there can be again two products, right? Because there are two beta position. This is one beta position and this is one beta position, and both of them have hydrogen, right? So two possible products are there. One is this. The other one is this, right? The double bond is here. Now for this, the double bond is here, right? Obviously, in this case, again, this is one, this is two. One is my major product, and this will be my minor product, right? Now, this comes from Zaitsev rule. Okay. Now, if at all you don't understand, people, take down the definition for Zaitsev rule. Take down. I'm giving you the definition for Zaitsev rule. In an elimination reaction, the double bond must be formed. The double bond must be formed between the carbon atoms. Which are more substituted. Right? So I'll repeat the statement, people. In a elimination reaction, the double bond should be formed between the carbon atoms which are more substituted. Right? So now if you look at the statement and if you look at this question, then you'll understand what is happening here. Now you see this carbon atom is not substituted, it's just having two hydrogen atoms, right? But if you look at this carbon atom now, right, this has two hydrogen atoms, one carbon atom, another carbon atom attached, right? So obviously the double bond is between, if you have a choice, right, if you have a confusion, remember that the double bond must be formed between the carbon atoms which are more substituted. Right? You cannot take this as the major product because this carbon atom is less substituted. That is why it is a minor product. But in this case, this carbon atom is highly substituted. So definitely this would have been the major product, because that is what Zaitsev rule says. During an elimination reaction, the double bond must be formed between the carbon atoms which are more substituted. Just like Markovnikov's rule. Right? Just like Markovnikov's rule, but that is for addition. This is for elimination. That's it. Okay, right. So now guys, now you understand, obviously this would be the major product. Okay, this would be the major product because this carbon atom is more substituted and this carbon atom is less substituted. So this is the minor product. So this would have been the major product. Okay, this would have been the major product. Right? Okay, fine. Any questions? Anybody has any doubts in what we saw now? Everybody understood Saitz's rule? Right? I hope everything is fine. Right? If there's anything, please let me know. Right? Okay, we'll go to the next question. Fine. If I ask you, okay, say 1, 2, 3, 4, 5. Now arrange them in the order of their acidic strengths. Okay, arrange them in the order of acidic strength. Either ascending order or descending order, doesn't matter.
Sir, then I think the order should be 5, 3, 2.
5, 3, no.
So is it 5, 2, 3?
Okay, 5, 2, 3, then
5, 2, 3, 1, 4.
5, 2, 3, 1, 4. Yeah, correct. Right. So the maximum acidic is 5, then comes 2, then comes 3, then comes 1, then comes 4. Okay, any reasons, Kana? Why is it like
It's
this?
because of the number of nitrogen group attached to the phenol, sir.
It's not nitrogen group, it is nitro group. Okay, so because of more number of nitro group, what will happen?
Yeah, I don't remember that phenomenon very correctly, sir. But
Yeah. Anyways, the answer is right. So people, I think the last class itself we saw, whenever you want to speak about acidic strength, right, it is directly proportional, right? The more and more is the acidic strength when the stability of the conjugate base is high. Stability of CV. CV is conjugate base. Right. First question, what is conjugate base? Can anyone tell me? What do you mean by conjugate base of an acid? What is this conjugate base?
sir, I think so is it because the nitro group stabilizes the phenoxide ion in phenol?
Okay, correct. Stabilize. Okay, fine. Why are you even taking into account of phenoxide ion? We're talking about phenol, right? We're talking about OH, right? Why are you talking about O minus here? Fine, that is first question. First question is why O minus are you talking? Second thing is how NO2 stabilizes O2, O minus, basically phenoxide. Two questions. If you answer it, the entire thing is correct. Okay, phenoxide. Yeah. Why are you telling O minus? I mean, that is phenoxide. Why are you not taking phenol? The answer lies here in the statement which I wrote. Okay, first tell me, what do you first, that's what I ask you, what do you mean by a conjugate base of acid? Like for example, if I ask you for HCl, what is the conjugate base? HCl is the acid, right? right? What is the conjugate base of HCl? Or say for phenol, OH, that is this thing, this is the acid. What would have been the conjugate base? Nobody knows. When is your exam, people? What date is your chemistry exam? Yes, what date is your chemistry exam? Have they announced? Hello.
Sir, is it a cyclohexane?
Sir,
Cyclohexane.
which one? Is it OH or?
Anything for HCl or say phenol, what is the conjugate base? First of all,
For
tell.
HCl, it is
So
Cl,
cyclophenol.
Cl minus.
Okay, correct. For HCl, it is Cl minus. For phenol, this one?
Phenol,
O minus phenoxide.
Phenoxide. Okay, this would have been the conjugate base. So what do you understand basically from the answers? After removing H plus from the acid, whatever is remaining is what is my conjugate base. So basically from acid, you remove H plus, what is remaining is my conjugate base. Remember this. Okay, so after removing H plus from the acid, whatever is remaining is what is called as my conjugate base of that particular acid. Right, so after removing H plus, the remaining one is Cl minus. After removing H plus, the remaining one is phenoxide, C6H5O minus. Right, so now when can I tell that that particular acid is a strong acid or weak acid is depending on the stability of the conjugate base. Right, so now like for you told it stabilizes the NO2 group, stabilizes O minus. Why O minus? Because that is the conjugate base of phenol. That is phenoxide is the conjugate base of phenol. That is the reason. That is the reason why we take phenoxide. Right, now how do you check for stability is the next question. Right, we have to understand that what is conjugate. We have to first understand what is the conjugate base. Second thing is how do you realize or how do you understand whether that particular species is stable or not is the next question you have to understand, right? So in this case, obviously, it is going to get stabilized by resonance, right? Now tell me people, with respect to charge, right? And if I compare it with stability, right? Are they directly proportional or inversely proportional? The amount of charge I have in a species, right? Is it directly proportional to stability or inversely proportional to stability? Charge in the sense, say for example, right, how do we say this? For example, we say that, right, we even discussed this when we, okay, now this is a tertiary carbocation, this is a secondary carbocation, this is more stable. A tertiary carbocation is more stable or secondary carbocation is more stable?
Sir, tertiary.
Okay, tertiary is more stable. Why?
Sir, is it because it's more substituted?
More substituted. Because of more substituted, what is going to happen? You guys lack basic. Yeah, please tell me. Someone was telling something. Yes, please go on. Okay. Right. So we already discussed this. I think nobody is taking notes. Literally nobody is taking notes. Because if you've taken down notes for the previous organic class, when we did the same kind of stuff, right? We told, if I ask you, how do you generally say that this is more stable than this? I gave you so much explanation for this. And none of you remember now is obviously because you are not in touch, right? You didn't take notes, or even if you have taken down notes, you wouldn't use it. You didn't even go through it after what we saw that time. That is the reason, right? These are simple things. If you write in your exams that tertiary carbocation is more stable because it is more substituted, they will give 0 mark, right? Or like this, whatever answer till now I heard from you, right? It stabilizes O minus, all these things, that blunt statements in organic chemistry will not work, right? You have to really go to the core, like say the basic understanding is required. Like certain things, if you didn't follow your 11th properly, right? I told you, like, I don't know. So some of you attended my class in 11th also. I told you 11th organic, if you're not going to concentrate, 12th organic is totally hard, very hard, right? We saw all of this, like we spent so much time during 11th class on this particular chapter, GOC, general organic chemistry. We spent so much time, so many questions we solved. At that time nobody asked, nobody understood how important these things are, right? If you understood that time, this time these kind of questions will be 1 minute answers, just like that. It should have just come very spontaneously it should have come, right? Like this simple questions, like say, like I really don't understand, like whenever your exam is, whatever be the date your exam is, you really are not ready. I think with respect to these chapters, at least, this is how questions will be asked. They'll ask you to explain why is it like this. You cannot give blunt answers. If you give blunt answers, accordingly only you'll get marks, right? Don't expect marks when you do not give perfect answers. You get perfect marks when you give perfect answers, right? This is really, I don't know, this is really what word should I use? Disappointing, right? Like your exams are going to come, and this is the level of preparation you guys are in, right? You really have to, when I'm telling you that you are really in a very risky position, then you have to understand that you are in the position, right? Because no way I see that you're going to get, other chapters, like say solutions, or I don't know, even P block, to some extent you'll be able to manage all the physical chemistry part if you know the formulas. But this is not like that. This is how questions will be asked, right? Fine. So anyways, here it is because when I can use inductive effect, right? Please understand, charge and stability are inversely proportional. More amount of charge you have, less and less the stable the molecule is, right? Charge and stability are inversely proportional. So among these two, whichever is going to have lesser positive charge, both of them have positive charge, right? Whichever is going to have lesser positive charge, that is going to be more stable, right? Now tell me, CH3 is what kind of group? I have two possibilities: electron withdrawing group or electron donating group. What is it? CH3 or any alkyl group R is what kind of group? Electron donating group or electron withdrawing group?
Electron withdrawing group.
No, they are electron donating groups. Remember this, right? All these are electron donating groups. Okay, right? So electron donating group means they will donate electron.
So then when they donate the electron, the positive charge will reduce.
Positive will decrease. Absolutely. Yes, correct. Right. So when they donate electron, they will donate electron on the next carbon atom only. Correct. And the next carbon atom is their positive charge. So obviously, because they're electron donating in nature, the positive charge gets decreased. Here also it gets decreased, right? But here you see, I have 3 methyl groups, that is 3 electron donating groups I have, right? But here I have only 2, right? So the positive charge here is highly decreased. Here it is somewhat less decreased, right? So obviously where I have lesser charge, only in tertiary I have lesser charge because I have more electron donating groups. And secondary is a little less stable because I have only 2 electron donating groups. The amount of positive is a little higher than in the previous case. That is why we say tertiary is more stable than secondary. Okay, right. So now that is with respect to inductive effect, right? Now with respect to resonance also, right? With respect to resonance, how stability is connected? Can you tell me? Directly proportional, inversely proportional. Resonance and stability are directly proportional or inversely proportional.
So
Basically,
directly proportional.
yes, generally what happens is more amount of resonance, right? More is the number
More
of
stability.
resonating structures, more is the stability. That
Yes, sir.
happens. Okay, right.
Yes, sir.
But again, here you have to understand is that there should be, what do you mean by resonance? Resonance is basically movement of charge.
Yes,
Is
sir.
it not? Movement of pi electrons. If you call it perfectly, if you have to define resonance, what exactly is resonance? Resonance is movement of pi electrons. Correct? So pi electrons can be either negative charge, right? Or it can be lone pairs, right? Or it can be pi bonds, right? Only these three you can move. The electron in the form of a negative charge, or the electron in the form of a lone pair, or electrons in the form of a pi bond. Only these things you can move, right? Now you see in phenoxide, okay, in phenoxide, I want oxygen to have very less positive charge. Obviously, lesser charge, more stability. How will I reduce the charge? The process of reducing the charge comes from resonance because the pi electrons are going to move. Now you see the negative charge, the pi electron in the form of a negative charge is going to involve in resonance. I hope everybody knows how to write resonance structures. This will come, this will break, this will break, this will break, all this will happen. So basically what you understand is the negative charge is distributed. Right? The negative charge is not there only on oxygen. It is getting distributed. Thereby, I can say that the amount of charge is getting decreased. Thereby, the amount of stability is getting increased. Okay. So whichever thing, whichever group, if I have here in this particular, say some X, right? If it can be an electron withdrawing group, right? If it can be an electron withdrawing group, right? Now it will pull electrons more easily like this. It will make sure that this negative charge is involving in resonance at better efficiency because it is going to be an electron withdrawing group, right? So if I have an electron withdrawing group, the amount of negative charge is very much decreased than when I have only oxygen, obviously, right? Because only oxygen, yes, resonance is there, but this X, if it is going to be an electron withdrawing group, it is going to help in this resonance, right? Because it is going to pull the electron towards itself. So these kind of groups are what are called as minus R groups. Basically, electron withdrawing groups will be called as minus R groups with respect to resonance, or minus I groups with respect to inductive effect. Depends on what operates. And in this case, resonance operates, so it is minus R, electron withdrawing group. Okay. Now next question is, right? Now obviously in this case, if I have an electron withdrawing group here, both minus R is activating as well as minus I is activating. For example, if I have taken NO2 here, right? Let me take O minus, right? That is basically only, why are we taking O minus? Because we're talking about stability of the conjugate base, right? This is the conjugate base, and we are going to take the stability of this only, right? Now this compared with O minus and NO2, if I have, right? As I told, NO2 is an electron withdrawing group. Okay, NO2 is an electron withdrawing group. Okay, electron withdrawing group, both by resonance as well as inductive effect, because I see nitrogen is a highly electronegative element. Obviously, it is going to pull the electron towards itself also. So that way it is minus I, as well as it is going to involve in resonance. And so because it is going to be minus R also. Okay, right. Now, if that's the case, obviously compared to this will be more stabilized because I know it is an electron withdrawing group by minus R as well as by minus A effect. Okay, right. Now what you understand is when I compare this also now instead of in the para question, this is para question. If I have NO2 in the meta question, whether it is going to help me or not is the next question. Okay, the answer is in this case only minus I dominates. Minus R is not working in this case. Okay, now how do you decide all this? Is very simple. Right, draw the resonance structure. I have O minus and I have my NO2. Okay, now what can happen? Say the first step, would be this making a double bond here, right? If this double bond breaks, this double bond can shift here and this can shift here, right? So basically it is in, this is how it is minus R effect, right? So if I write the resonance structure now, it would have been double bond O. This bond is shifted here, so I would have had double bond N, and this bond would have broken and gone to oxygen, so it would have been O minus, and this still remains. This bond is not there, this bond would have been there. Anyways, so what you understand is this is helping me in resonance if I have it in para position, right? But if I go to meta position, same thing, O minus. If I have NO2 here, right? Now check, now this will come here. Now say this would have come here, and this bond cannot go here, it has to come here. Hope you understand what I'm trying to say. This, okay, if I draw it step by step, say the first step is this, okay, first step is this, and this bond would have gone to this, making a negative charge. So now I would have had double bond O, and this bond would have been broken to form a negative charge here, and there is a bond here with an NO2, and the other bond still stays. Okay, now the next step, right? Next step is that this pair of electron can come here and make a bond, and this bond cannot shift here. Please understand, right? The bond has to go to the next carbon. This only will happen. The next will be O minus. Now there will be a bond here, and the NO2 staying as such, it is not doing anything, right? And the bond has shifted here, and this bond would have gone here to make a negative charge. Obviously, the last step would have been this would have, oh yeah, there's a double bond over here, right? This bond would have come here, and this would have gone back. So what you understand is when I have NO2 in the meta position, right, it is not involving in resonance at all. It is as if, it is just as if only O minus is there. If only O minus is there, this is exactly what would have happened, right? So whether I have NO2 in the meta position or whether I don't have, the resonance structures are not changing. But look at this. When I have it in ortho or para for that matter, if I had NO2 here, definitely in both these cases, it would have increased, it would have stabilized my O minus through resonance as well. Okay. Whether inductive effect is having, we'll understand later. But if it is in ortho or para position, definitely it will stabilize the O minus by resonance for sure. Okay. If it is in ortho or para position, it will activate, it will stabilize my O minus. NO2 will stabilize the O minus, that is phenoxide, right? But if it is in meta, no, it is not going to stabilize by resonance, right? And then it doesn't mean that it is not stabilizing at all. If it isn't, if minus R, minus I both will activate. If it is in para, no. Okay. If it is in ortho, both R, minus R and minus I will activate, because now remember, inductive effect is distance dependent. Right, inductive effect is distance dependent in the sense that if this group is very close to the O minus, then it will be able to involve in inductive effect. But if it is very far, say if it is going to be here, the distance between this and this is very large, right? At that time, inductive effect cannot dominate, cannot be operating. Okay, that is why we say that inductive effect is distance dependent, right? Right. So what I understand is if I have this NO2 in ortho position, obviously by resonance it stabilizes. And since it is very close to the O minus, inductive effect also, it is going to decrease the negative charge, thereby increasing the stability. Okay. Right. Now, if it is going to be in meta position, right? If it is going to be meta position, what I understand, it is not involving in resonance, but still it is little close to the O minus only, right? Even though it is not involving in resonance, this nitrogen, it is little close to this oxygen only. So minus I effect still dominates and still is operating, but resonance is not operating, obviously, right? And if I have para, right? If I have para, obviously the nitrogen will be very far away from this carbon. So, but it is not stabilizing by inductive effect, but definitely by minus R effect, it is stabilizing. Even though inductive effect is not happening, resonance is happening. Okay, now next question is, which is stronger? Resonance or inductive effect? Which is stronger? The answer to this question is resonance is the stronger one. Okay, we have to take resonance to be the stronger one than the inductive effect. Okay, right. So now what I understand, if it is only phenoxide, there is just resonance happening, only minus R, not even minus R, only resonance is happening, right? But if I have NO2 in the ortho position, both minus R and minus I is happening. If it is in meta position, only minus I effect is happening, right? Fine. So now obviously what I understand is this will again be more stable. More stable means obviously the OH, if I had OH here, this would have been more acidic than in this case. Okay. So going back to the question, what I had, right? So obviously now what you understand is here I have ortho position, here I have meta position. Now this particular compound you see, all the ortho and meta positions, ortho and para positions, ortho, para, all ortho and para positions are occupied by electron withdrawing groups. That is NO2, right? Obviously the first rank goes to fifth one because it has 3 electron withdrawing groups, all of them in ortho and para position. So definitely this will have minus R minus I, this will have minus R, this will have minus R and minus I. All of them will be present. Okay, right, fine. Now obviously comparing CH3 is an electron donating group. Know this. So definitely that is going to destabilize the O minus. Right now already I have O minus. This is going to donate electron to O minus, thereby destabilizing it. So definitely this is going to come at the last. Right? Because NO2, 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 all of them are stabilizing in some form, either minus I or minus R. But this is destabilizing by plus R and plus I. Okay, CH3, all these things will be, even if I have one more OH or say one more NH2, all these things, whenever I'm able to donate electron, that all will be minus, plus R and plus I, which will be destabilizing the OH minus, O minus. Okay, so this obviously comes at the last. 4 comes at the last, and we understood why 5th comes in the first, because it has 3 electron with the drawing group present. Okay, right. Now, obviously, now the comparison between this and this we already discussed, right? Now, this has an electron with the drawing group, right? So obviously, this will come first, this because it has both minus R and minus I, and this only has minus I. So obviously, after that 3 comes. And this has no electron donating, no electron withdrawing, not stabilizing, not getting destabilized. Obviously 1, and then comes your destabilizing one, that is my CH3. Right, guys, I want everybody to put a S if they understood, or if not, please tell me, sir, repeat again. I will repeat again. Go put it in the chat box or unmute yourself and tell me whether you understood or not. Please go for it. Okay, yes. Others, please tell me. Is it okay? You can unmute and tell, or you can just ask me to repeat again or put in the chat box, whatever it is. But I want everybody, I want to know from everyone whether you understood or not. Okay, Satyapriya, yes. Okay, good. Others, yes. If you want me to repeat again, please tell me. I will repeat again. Everybody's okay. Yes or no? Guys, I'm still waiting. Are you guys there? Are you okay? Everybody understood why is the order like this? 5, 2, 3, 1, 4. Everybody understood? Sure. That's what I'm telling you. You can always ask me. There is nothing wrong in asking me, sir, one more time, please. There is nothing wrong. Okay. Now, first you have to understand this: electron with the drawing group will stabilize O minus. Is it not the phenoxide ion? When I remove the H plus, I talk about the stability. The first point you have to understand is this, right? The acidic strength is directly proportional to the stability of the conjugate base. The conjugate base of phenol is phenoxide ion, O minus, right? If this becomes stable by some effect, then I would say that that particular phenol is highly stable. Okay, right. Now what I have to understand is NO2, right? NO2 is an electron with the drawing group. Okay, electron with the drawing group, both by R as well as by, that is both by resonance as well as by inductive effect. Okay, right. So now if I put NO2, basically electron withdrawing group means what? If I have O minus here, it will withdraw electrons from O minus, decrease the negative charge, making it more stable. right? Because I told you less charge, more stability, right? Less negative charge or positive negative doesn't matter. Less charge, more stability, right? So since it is an electron withdrawing group, it is going to decrease the negative charge, thereby stabilizing the phenoxide ion, right? Now what you have to understand is, if NO2 is in the ortho position, if you look at the resonance diagram which I have drawn, where is it? Right, now look at this. Look at the resonance structures. O minus is there. Now NO2 is in the ortho position. Right, NO2 is in the ortho position. See, it is able to take part in the resonance. Right, it is able to take part in the resonance and by decreasing the negative charge. Right, so definitely it is stabilizing the phenoxide ion by minus R effect. And one more thing is, this NO, this nitrogen is a highly electronegative element. Right, so since this nitrogen is a highly electronegative element, it is going to again pull electron towards this nitrogen, thereby minus I effect can also happen. Okay, electron withdrawing group, minus I effect. Electron donating group, plus I effect. Okay, right. So minus I effect can also happen. So both by resonance as well as by inductive effect, this NO2, if it is in ortho position, is stabilizing the phenoxide ion. Right, now look at, go to meta position. Right, now you will understand that this resonance is happening, but this NO2 is not taking part in the resonance. Right, so it has no minus R. Minus R is not there. It is not taking part in the resonance. Right, but again, one more thing will operate is, since nitrogen is electronegative, again I can still have some kind of inductive. So minus I effect is still happening, but resonance is not happening. Okay, but if you go to para, right, if you check for para, if I had NO2 here, inductive effect cannot happen because it is very far away. Right, inductive effect cannot happen because if it is very far away, but minus R will happen. Right, that is what I've mentioned here. In ortho, both minus R and minus I will activate. If it is M, that is meta, only minus I. If it is para, only minus R will happen. Right, so keeping all this in mind, what I understand is, for phenols, right, electron withdrawing groups in ortho and para positions will increase their acidic strengths. Okay, I mean, not question mark, this is a statement. Okay, for phenols, electron withdrawing groups in ortho and para positions will increase their acidic strength, and opposite, obviously. Right, electron donating group will decrease the stability, decrease the acidic strength, that is for sure. Okay, right, now you go back to the question now that you understood this. Right, now you see, in fifth molecule, in compound number 5, ortho, para, all the possible ortho and para positions are occupied. Right, obviously this would have been maximum stabilized, the phenoxide ion, so obviously maximum acidic. So obviously the first rank goes to 5. Right, now check, I have, this is CH3 electron donating group, and this doesn't have anything, but these two, that is 2 and 3, still has electron donating, electron withdrawing group. NO2 is here, NO2 is here. Now you have to concentrate on which is more dominant. Now remember, resonance is more dominant than inductive effect. Right, which is stronger. Resonance effect is stronger than inductive effect. Okay, so in this case, if it is going to be in ortho, as we have already discussed, minus R and minus I will stabilize. But in this case, if I have only meta, only minus I will stabilize. So obviously minus R minus I stabilizing is more compared to only minus I stabilizing. So compared to 2 and 3, obviously 2 comes first, then comes 3. Right, now why 1 or 3? 3, 4 obviously comes at the last, because this is going to be an electron donating group here. Right, and 1 comes next because it does nothing, neither electron donating group nor electron withdrawing group, so that 1 comes in between. Okay, now is it okay, Kanna? Everybody understood? Now can I get a yes from everybody? Whomever didn't tell yes.
Yes, sir.
Okay, one only guy got. Others? Okay, okay. Right, I hope everybody is following. Right, I hope everybody's fine, everybody's doing good. Okay, fine. We'll move on to, guys, you really lack your basics. Now only I'm telling you, please go and read this chapter, 11th General Organic Chemistry. Please go and read this. Okay, you will get so much clarity for all the things which you're studying now. All the basics are there in 11th only. Okay, so please do go and do it. Okay, fine. Next questions. Next question I'll ask. Say, I want to convert benzene to okay, yeah. So I want to convert benzene to this one. I'll give you 5 minutes time. Work on it.
So is it nitration process? This one.
Okay, fine. Then what is the nitration? What is the reagent?
FeCl, sorry. HNO3 sulfuric, HNO3 and sulfuric acid.
Sulfuric acid formula? Suddenly you forgot sulfuric acid formula. What is it? Sulfuric acid, anybody can help him? Formula?
HNO3 and H2SO.
Ah, good. Right. So first is nitration. Correct. H2SO4 plus HNO3. Correct. Okay. Next step. So if you put nitration, obviously NO2 will come. How will I get Cl?
Cl chlorination process.
What do you do? What do you do for chlorination? What is the reagent?
Ferric chloride.
That's it. Only ferric chloride?
Or is it anhydrous?
No, fine. Ferric chloride is there. Other than the ferric chloride, what other reagent? What other things should I add? Okay, right. You almost got the answer. Good. Anybody wants to tell me what is this Friedel-Crafts halogenation? That is chlorination, bromination. So if I have benzene, how do I convert it into chlorobenzene? What do I do here? What should come here?
If it's chlorination, Cl2 and
Then
Cl3.
correct. Right, it is going to be Cl2 in the presence of FeCl3. FeCl3 is the catalyst.
And from there, we need to perform nitration first.
No. Now look at this. That is the trick here, right? For this particular reaction, for this particular conversion, you have to do nitration first. HNO3 plus H2SO4, right? Now you will form, like say NO2 here, right? Then you have to go for chlorination, that is Cl2 in the presence of FeCl3, you will end up with this product, right? Now, why am I doing the opposite? First, I would have done chlorination, then I would have got nitrate, then I would have done nitration. How would I have gone the same product or different product? Or what will be the difference? For example, if to this, first I did chlorination, right? Now I go for HNO3 and H2SO4. What would have been the product? Cl, NO2 will be where?
The fourth position.
Basically here or here in this position, either ortho position or para position. Why? Because chlorine is ortho para directing. What do you mean by directing? Whichever is the second group, it's incoming group. In this case, NO2 is the incoming group. The incoming group will be directed towards ortho and para positions if I already have chlorine present. Even OH is also an ortho para directing group. NH2 is also an ortho para directing group. So what you have to understand is all electron donating groups are ortho para directing groups. All electron withdrawing groups like say NO2, CN, C double bond O, all of them will be meta-directing groups. Okay, right? So first, if I put chlorine and then I go for nitration, I will get NO2 at the para position. I mean, ortho position or para position, not in the meta position. But look at where do I want? I want, where is it? Yeah, I want NO2 to be in the meta position. So what I have to do? Obviously, first, if I do nitro, then if I do chlorination, the first group already present here is NO2. This is meta-directing, right? So the incoming chlorine will go to the meta position. So this and this are nothing same, right? Cl and meta, Cl and NO2 are meta to each other. They're in meta positions. Okay, so these kind of things you have to be very, very careful. You have to look at whether they're in ortho or para or meta. Accordingly, you have to choose which you have to do first. In this question, I want meta, so I want nitrogen NO2 to be first present there. Then if I do chlorine, then the chlorine will go to the meta position. But if I do chlorine, then do nitration, NO2 will come in the ortho position or in the para position. Yes, guys, understood the difference between the two methods? In this case, this is what is correct, what we did here. First nitration, then chlorination, not the other way around. Yes, okay, everybody is fine? Is it okay, guys? Everybody understood? Yes, no?
Yes, sir.
Okay, very reluctantly I'm getting an S, but fine. Anyways, guys, I think we'll stop this for today. Okay, right? You go prepare for your exams, whichever the exams you're preparing. Please go prepare for your exams. We have 15 more minutes. You can go take rest. Okay. Any questions? Anybody has anything specific? Anybody has? Anybody wants to ask me anything specifically? So this doubt I have, that doubt I have. Anybody wants to ask me anything? Okay, if that's the case. Okay, that's the case. Thank you so much, people. We'll meet again. I'm ending the class. Thank you so much.
Thank you, sir.
Thank you.
Thank you.
Thank you. Thank you.